My project makes use of Uber Movement, which is an open data set that shows, among other things, travel times between different points in a number of different cities. And this is always being expanded. So the two cities I'm comparing are Miami and Los Angeles. So when we're talking about categorical nodes, those are the two categories of the nodes that I'm using. Category being city, and the two options being Miami and Los Angeles. And when you pull data from here, you can divide it by traffic analysis zones or by census tracts. I'm using census tracts. And so when you pull this data in, you can see that every point has a source ID, which is a census tract, and it's the origin of the trip, and the destination ID, which is another census tract, and that's the destination of the trip. This variable hour of day is a value from 1 to 24, and can also be useful in later analysis, in that you can, for example, you can divide into a time of day and create another categorical variable, but that's out of the scope of this project, as that doesn't vary from one node to the next. So in this case, the categorical variable for the nodes is the city. And when I'm looking at the network, I'm using mean travel time as the weight connecting one node to another. So I pull these in separately. I'm calculating the centrality measures for each city individually. And then I'm sorting that so we can take a look at some of the top nodes in terms of measurement. So for example, if you look at like the top 10 here, to get some of the centrality measures, when we compare the two cities in terms of degree centrality, they're more or less on par with one another. And so that's just about which nodes are connected to one another. But then when you look at eigenvector centrality, you see much higher values for Miami. Which can potentially be used for sort of analyzing traffic patterns. In the case of this set, one trip is really just going from one node to the next, but if you want to kind of see traffic patterns as to where a car might travel throughout the city, you want to kind of look for nodes with higher values of eigenvector centrality. And visualizing that sort of shows the same thing. Miami is up top. The blue values are eigenvector, the green are degree centrality, and you see it for Los Angeles. It's much more weighted on the lower end, which kind of shows that the much greater connectivity in the city of Miami. In terms of the actual sample size, it is of a larger set for Los Angeles. There's about 2,600 different nodes, whereas for Miami we have 1,200 different nodes.